Last time, in our short video, we answered a big question. What is programming? Today, let's go deeper together. Before you actually start typing code, you should understand why programming matters, where it shows up in real life, and most importantly, why we're beginning our journey with the C language. Think of programming as giving step-by-step instructions to a very fast, very literal assistant. If the instructions are clear and ordered, the result is reliable. If the instructions are vague, the result is unpredictable. That's why good programs feel like good recipes. Let's take a simple example you already know: making a cup of tea. First, boil water. Then, add tea leaves. Next, add sugar and milk. Finally, wait, strain, and serve. If you change the order, say, add milk before you've even heated the water, you'll get a strange result. Computers work exactly the same way. They don't guess your intentions, they follow the steps you give. Because of that, programming is really the skill of breaking big goals into small, precise steps. We call that decomposition. You'll do it every day as a programmer. Take a complex feature like build a login system, and break it into tiny tasks, design inputs. Validate them. Check the database. Create a session. And show helpful errors. Why does this matter? Because everything around us is powered by code. The apps we open every morning. The websites we read. The smartwatches counting our steps. The cars that can almost drive themselves. And the large AI models you keep hearing about at the end of the day. They all run instructions written by people like you. Programming is how we create technology instead of just consuming it. There's also a mindset benefit. Programming trains you to think clearly under constraints. You learn to name things well, to test assumptions, and to fix your own mistakes. That mindset translates to real-life planning a trip, organizing your study routine, or managing a small business. It's problem-solving with feedback you can see on the screen. Now, why start with C? People often ask, should I begin with Python or JavaScript because they look easier? Those languages are fantastic and we will absolutely use them in this series. But C gives you something precious at the start. It shows you what's actually happening under the hood. When you learn C, you still write instructions. However, you also learn how memory is managed, how data is stored, and how the computer truly executes your commands. C is called the mother of programming languages for a reason. Many modern languages borrow C's syntax and core ideas. If you recognize A for loop or an if statement in C, you'll recognize it almost anywhere. In C++, Java, C#, JavaScript, and even in many parts of Python's structure. Learning C is like learning the grammar of programming itself. Another reason to start with C is that it builds strong logic. Because the language is minimal, you can't hide behind too many shortcuts. You'll practice thinking about problems step by step. You'll understand how variables live in memory, how arrays map to consecutive locations, and how functions pass data. Later, when you move to higher level languages, you'll write cleaner, faster code because you built your foundations on rock, not sand. Universities across the world still teach C first. Not because it's trendy, but because it connects you to computer science fundamentals. When you write a C program and then compile it, you are literally transforming your human-readable instructions into machine code. That path from source code to executable teaches you how compilers work, what optimization means, and why tiny mistakes can crash a program. Let's tie this back to our T example and push it one level deeper. In a high-level language, you might say, make tea, and the system handles many details for you. In C, you'll learn what make tea actually involves. Heating water with a timer, checking a temperature threshold, handling edge cases like no kettle found, and cleaning up resources when you're done. That attention to detail is not a punishment. It's training that makes you a careful engineer. Now imagine some everyday examples of programs you could build as a beginner. A small command line calculator that adds, subtracts, multiplies, and divides. A habit tracker that logs your study sessions to a file and reports your streak. A mini game in the terminal that asks questions and keeps score. Or a simple sensor logger on a microcontroller that reads temperature every minute and writes the results for later analysis. All of these are doable with C, and each one teaches you a new building block. As you practice, you'll see common patterns appear again and again. You'll read input, validate it, and store it. You'll loop over lists of numbers or characters to find a match or computer result. You'll create functions to reuse logic cleanly. Later, you'll learn pointers to point directly at memory, which unlocks powerful techniques for working with arrays, strings, and dynamic data. These ideas are the backbone of efficient programming. Of course, you might be wondering about speed. C is extremely fast because it's close to the hardware. When performance matters, games, operating systems, embedded devices, or high-frequency trading, C is often part of the stack. Even if you never write a full app in C, understanding it helps you write faster Python or JavaScript, because you'll know what's cheap and what's expensive on a computer. Let's also talk about debugging. Everyone makes mistakes. Good programmers just find them faster. In C, you'll meet helpful tools like the compiler's warnings and a debugger that lets you step through your program line by line, watching variables change. That moment when you spot a tiny logical error and fix it, that's when you realize you're not just writing code. You're learning to think precisely. By the way, learning programming doesn't mean memorizing everything. It means knowing how to ask clear questions, how to search documentation, and how to test ideas quickly. In this series, I'll show you how to plan a small project, write a first version quickly, and iterate until it works. You don't need permission to start, you just need curiosity and a little discipline each day. So what will we do next? In the upcoming episode, we'll install a C compiler, write our very first C program, and understand exactly how that program travels from your editor to the machine that runs it. We'll print text, take input, and play with variables. Then we'll explore conditions and loops, the basic tools that let you build logic from simple pieces. Before we wrap up, here are 3 quick tips. 1. Name things clearly. Good names make your future self say thank you. 2. Keep your functions short and focus. Small pieces are easier to test and reuse. 3. Write comments. For humans, your code runs on a computer, but your future collaborators will be people. To recap, programming is about giving clear, ordered instructions. It's everywhere around you, and it changes the way you think. We're starting with C because it teaches you the core ideas deeply and makes every other language easier to learn. If that sounds exciting, you're already on the right path. In our next video, we'll dive into C with hands-on examples. Make sure to subscribe and join me step by step on this journey. This is Code and Beyond, and together, we'll master the fundamentals of computers and coding.